you ever looked at a list of ports during a scan and thought, what the heck is running on all these? Or maybe you've seen TCP versus UDP pop up on a test and couldn't remember which one does what. Whether you're prepping for Security Plus, troubleshooting weird network issues, or diving into tools like Nmap, understanding ports and protocols is an absolute must in cybersecurity and networking. In this video, we'll discuss what ports and protocols are, the differences between TCP and UDP, go over the most common ports you'll see, and how this applies to the real world. Let's get into it. When two computers want to talk to each other over a network, they need to agree on how that conversation happens and where to send the messages. That's where protocols and ports come in. Protocols are like the language or rules that devices use to communicate. Think of them as the grammar and structure of a conversation. You may have heard of a few of these already, like HTTP for browsing websites, SMTP for sending emails, or FTP for transferring files. Each protocol has a specific job and they follow a strict set of rules so that devices on both ends can understand each other. But protocols alone aren't enough. We also need to know where on a device a certain service is running, and that's where ports come in. A port is like a virtual door on a device. Each service, like a web server or an email server, listen on a specific port. So when data comes in, your computer knows exactly which service should handle it. For example, websites using HTTP usually listen on port 80, whereas secure sites using HTTPS listen on port 443. And remote access via SSH, that's typically done on port 22. Now there are 65,535 ports in total, and they're split into ranges. Well-known ports using port 0 to 1023 are used by core system services. Registered ports ranging from 1024 to 49,151 are typically used by applications and software vendors. And dynamic ports or private ports ranging from 49,152 to 65,535 are used temporarily by clients. Now this last range is where ephemeral ports come in. These are a subset of dynamic ports automatically assigned by the operating system for short-lived client-side connections. And the key difference is that dynamic ports can be manually assigned, while ephemeral ports are always temporary and client assigned. So when your computer connects to a website, it might use a random port like 53,821 on your end, but it'll send that request to port 443 on the web server because that's where HTTPS is listening. Together, protocols define how data is structured and transferred, while ports define where that data should go. Now that we know what ports and protocols are, let's talk about two of the most important transport protocols in networking, TCP and UDP. Both of these protocols help move data between devices, but they do it in very different ways. TCP, or Transmission Control Protocol, is all about reliability as opposed to speed. It sets up a connection between two devices before sending data, kind of like making a phone call. It guarantees that the data arrives in the right order and checks for errors along the way. If something does go missing or arrives out of order, TCP will detect it and request a resend. This makes TCP ideal for things like web browsing, emails, and file transfers. In short, if you need accuracy and completeness, TCP is the protocol for you. On the opposite end of the spectrum, we have UDP, or User Datagram Protocol. This protocol is much faster, but doesn't guarantee delivery. It just sends the data and hopes for the best. No handshakes, no acknowledgements, just spray and pray. That makes it much faster and lowers overhead, but it's also riskier if the data gets lost or scrambled. UDP is great for things like live video or audio streaming, online gaming, or voice over IP. If you've ever been watching a video on a streaming platform like YouTube and the video starts to buffer, or the video quality looks like you're watching it on a potato, it's because you're either dropping packets or receiving the data out of order, which is a common issue with UDP. Basically, if speed matters more than reliability, UDP is a solid choice. Here's an analogy to help reinforce the concept. TCP is like sending a certified letter with tracking and delivery confirmation. UDP is like dropping a letter in the mailbox. It's quick and easy, but there's no guarantee that it gets to its destination. Let's go over some of the most common ports you'll see in networking and cybersecurity. These are the ones you'll want to recognize instantly, whether you're scanning a network, configuring a firewall, or reviewing logs. And if you're taking a networking or cybersecurity certification exam like CompTIA Network Plus or Security Plus, these are commonly included in the exam objectives. For web traffic, we have port 80, which runs HTTP and is used for unencrypted web traffic. This was the standard before HTTPS took over. Now, HTTPS uses port 443 and is used for secure encrypted web traffic. This is the port your web browser uses when you see that little padlock icon in your address bar in your web browser. For remote access, we have Secure Shell, which is used for securely accessing and managing remote systems over command line, especially in Linux servers and networking equipment like switches. We also have Telnet, which is very similar to SSH, but sends that traffic unencrypted and uses port 23. Remote Desktop Protocol, or RDP, is used to connect Windows systems with a graphical user interface and uses port 3389. For email, we have Simple Mail Transfer Protocol, or SMTP, and this is used for sending emails and uses port 25. Now, a more secure version that uses authentication operates on port 587. POP3 is used by email clients to retrieve messages from a mail server and uses port 110, where Nmap, which retrieves emails with more advanced syncing across devices, uses port 143. For file transfers, we have FTP, or File Transfer Protocol, which is used for unencrypted transfers and uses ports 20 and 21, where port 20 handles the file transfer itself and port 21 handles commands and responses. We also have a more secure version called Secure File Transfer Protocol, or SFTP, which actually runs over SSH and is fully encrypted. And because it's using SSH, it uses port 22. There's also FTP Secure, or FTPS, which adds TLS encryption to traditional FTP and uses port 989 and 990. Domain Name System, or DNS, translates human-readable addresses like tacobell.com into an IP address that computers can understand, and this uses port 53. Now, it is worth noting that this works over TCP and UDP. Finally, we have a few ports that don't fit cleanly into the earlier categories: SNMP and SMB. SNMP, or Simple Network Management Protocol, is used for monitoring and managing network devices, and this uses port 161. SMB, or Server Message Block, is used for Windows file sharing and networked printers. This uses port 445. Now, I understand that was a lot of ports, and you don't need to memorize every single one of them, but knowing the key ones can help you quickly recognize traffic patterns, identify suspicious activity, and better understand how systems interact on a network. Let's go over a few areas where knowing your ports can save you a ton of time and be applied in a real-world situation. If we're running tools like Nmap or using vulnerability scanners, you'll see open ports listed. Knowing what these ports represent helps you quickly identify what services are running and whether they should be. Port 22 open? That's probably SSH. Is port 3389 open on a public-facing system? That might be a risk because it's a remote access protocol. Firewalls also use port numbers to decide what traffic to allow or block. Want to allow web traffic? You'd likely want to open ports 80 and 443 for HTTP and HTTPS. Want to block file sharing? You might look into blocking things like SMB on port 445. Understanding ports helps you write smarter firewall rules and troubleshoot network access issues. We can also potentially identify malicious traffic, especially if we see traffic for telnet on port 23, or outbound traffic over an uncommon high-numbered port, and that could potentially indicate that there's a misconfiguration or perhaps even a compromise. In penetration tests where ethical hackers hack our network to find vulnerabilities or capture the flag events, port scanning or enumeration is often the first step. From there, you can identify weaknesses, like a misconfigured web server on port 80, or an FTP service running on port 21, or perhaps you have open SMB shares running on port 445. Recognizing these quickly helps you assess the attack surface, find potential entry points, and give you quick, easy wins. So that's how ports and protocols work. They're the foundation for communication across networks. Whether you're analyzing traffic, writing firewall rules, or scanning for vulnerabilities, understanding them helps you recognize what's normal and what's not. And that's a key skill for anyone in cybersecurity or networking. If you enjoyed this video, please consider subscribing to the channel or checking out one of the other videos on screen. Thank you so much for watching, and I'll see you in the next one. Take care.